Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 11 video on the chapter of parallelograms, where I will solve the problems of exercise 16b from the textbook of author RS Aggarwal. So these are all multiple choice questions based on the entire chapter of parallelograms. This video is part of the playlist CBSE Maths for Class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I hope you have watched all the previous parts, that is part 1 to part 10, where I have thoroughly covered all the concepts of the parallelograms, quadrilaterals, and all the special parallelograms like rhombus, rectangle, kite. Kite is not a parallelogram. All the special quadrilaterals, square, rectangle, trapezium, kite, rhombus. I have thoroughly covered all these geometrical figures. So let's get started with part 11 video in solving the exercise 16b problems on the chapter of parallelograms. Okay, so I hope the problems on the left hand side of exercise 16b, you can read them. It's big enough so that you can read them. If not, I will read out the problems while solving it. On the right hand side, I will solve the problems. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. So let's start solving the problems. These are all multiple questions. Only one choice, 4 choices are given, and one choice will be correct. Question number 1 says the two diagonals are not necessarily equal in a rectangle. In a rectangle, the diagonals are equal. It is saying that the two diagonals are not necessarily equal in which of the following figures. So in rectangle, the diagonals are always equal. So it is choice A is not correct. Square, the diagonals are also equal. Rhombus, the diagonals may not be equal. Isosceles trapezium. In isosceles trapezium also, remember that the diagonals are equal. So the correct choice is C, that is rhombus. In only rhombus, the diagonals are not necessarily equal. Okay. Question number 2. The lengths of the diagonals of a rhombus are 16 centimeter and 12 centimeter. Then length of each side of the rhombus is. We have done this exact same problem in the previous exercise, that is 16a. Anyway, let me again do it. So basically the concept is in a rhombus. So let's say the rhombus is something like this. Now, so we have the rhombus. So let's say ABCD is the rhombus. ABCD is the rhombus. The diagonals are of unequal length. One is 16 centimeter and other one is 12 centimeter. We know in a rhombus, the diagonals in this figure, AC and BD, they will bisect each other at right angles. So this will be right angle. Let's say they are bisecting at the point O. So it is given that AC is equal to 16 centimeter and BD is given to be 12 centimeter. Now, since the diagonals bisect each other, we will have AO will be equal to half of AC, which is equal to half of 12 centimeter, which is equal to 6 centimeter. Also, we will have OB will be half of BD, which is equal to half of sorry, AC was 16 centimeter. AC was 16 centimeter. So this will be 8 centimeter, and we have half BD 12 centimeter. This is equal to 6 centimeter. Okay. Now in the right angle triangle, in triangle AOB, it's a right angle triangle. Since the angle AOB is 90 degree, because the diagonals are bisecting each other at right angles, we will have, applying Pythagoras theorem, we will have AB square is equal to AO square plus OB square. Now what is AO square? AO square is 6, this is 8 square plus 6 square square centimeter. This is equal to 100 square centimeter, which can be written as 10 square centimeter. So this implies AB will be equal to 10 centimeter. So the length of each side of the rhombus is 10 centimeter. So the correct choice will be, answer is choice C. Answer is choice C. Okay, let's do question number 3. The two adjacent angles of a parallelogram are 2x plus 25 degree and 3x minus 5 degree. The value of x is, okay, since the adjacent sides, any two adjacent sides of a parallelogram are supplementary, we will have 2x plus, so if this is the parallelogram, in a parallelogram, the sum of any two adjacent sides, it can be A and B, it can be B and C, it can be C and D, or A and D. The sum of any two adjacent sides, let's say these two, it is always 180 degree, that is, they are supplementary. So let's say angle A is 2x plus 25 degree, and let's say this angle is 3x, angle B is, so let angle A is equal to 2x plus 25 degree, and angle B is equal to 3x minus 5 degree. Now angle A and angle B are adjacent angles in parallelogram ABCD. So this will imply that angle A plus angle B should be equal to 180 degree. So this implies angle A is 2x plus 25 degree plus angle B is 3x minus 5 degree. This is equal to 180 degree. Simplifying the left hand side, we get 5x plus 20, this much degree is equal to 180 degree. So this will implies, ignoring the degree, we have 5x plus 20 is equal to 180. So this implies we have a linear equation in the variable x. We can easily solve it. 5x is equal to 180 minus 20, which is equal to 160. So this implies x is equal to 160 divided by 5, that is 32. So x is 32. So this implies, what is it asking? The value of x is, so x must be equal to 32. So the correct choice is B. The correct choice is B. Okay, let's do problem number 4. The diagonals do not necessarily intersect at right angles in a parallelogram. In a rectangle, the diagonals do not necessarily intersect at right angles. Rhombus and kite. The diagonals do not necessarily intersect at right angles. Now, in a rhombus, the diagonals intersect at right angles. In a kite, also the diagonals intersect at right angles. In a rectangle, the diagonals do not intersect at right angles. And also in a parallelogram, the diagonals do not intersect at right angles. So the choices should be A and B. The diagonals do not necessarily intersect at right angles in a there are two choices, as I can see. It will be A in a parallelogram, and in a rectangle the diagonals do not necessarily intersect at right angles. Only in rhombus and kite they always intersect at right angles. I'm not sure why two answers are correct. These are multiple choice questions. Only one choice should be correct. But choice A is parallelogram. In parallelogram, we know that the diagonals do not necessarily intersect at right angles. The diagonals do not necessarily intersect at right angles in a parallelogram. Rectangle. Okay, the answer is A and B. Question number 5. The length and breadth of a rectangle. The length and breadth of a rectangle are in the ratio 4:3. If the diagonal measures 25 centimeter, then the perimeter of the rectangle is. So we have the rectangle. Let's say ABCD is the rectangle. It is given that the diagonal, the length and breadth of the rectangle are in the ratio 4:3. So we can say that, let's say, let length AB is equal to x centimeter, and breadth based on the ratio breadth BC. The ratio is given as 4:3. So this will be 4x centimeter, and this will be 3x centimeter. Based on the ratio, it is given that AB is to BC is equal to 4:3. So based on this ratio, we are assuming that the length AB be equal to 4x centimeter and breadth BC is equal to 3x centimeter. The diagonal is given to be 25 centimeter. So the diagonal AC, in a rectangle the diagonals are equal. So we know that using Pythagoras theorem, in triangle ABC, we will have the diagonal AC square will be equal to AB square plus BC square. This is equal to AB square is 4x square and BC square is 3x square. Now this implies AC is given to be, the diagonal AC is diagonal which is given to be 25. So we must have 25 square is equal to 4x square plus 3x square. This implies 25 square is 625 is equal to 16. 4x square is 16 square and 3x square is 9x square. So this is equal to 25 xs square. So this will imply xs square is equal to 625 divided by 25, which is 25. So this implies x is equal to square root of 25, which is equal to 5. So x is what is then the perimeter of the rectangle. Okay, so length will be equal to 4x centimeter, which is equal to 4 into 5 centimeter, which is equal to 20 centimeter, and breadth will be equal to 3x centimeter, which is equal to 3 multiplied by 5 centimeter, which is equal to 15 centimeter. Okay, this implies perimeter we know is equal to 2 into length plus breadth. This will be equal to 2, length is 20, breadth is 15, this much centimeter, which is equal to 70 centimeter. So the perimeter will be 70 centimeter. Hence, the correct choice is C is the correct choice. Okay, let's do question number 6. The bisectors of any two adjacent angles of our parallelogram intersect at. Okay, so this is a good question. So if we have any parallelogram, if we consider any parallelogram, let's say ABCD is a parallelogram, it is saying that the bisectors of any two adjacent angles, let's consider the adjacent angles D and C. So the bisector of angle D, let's say, is this. Let's say it is DE, and the bisector of the angle C, let's say, is this, and they intersect at the point E. We have to prove that angle DEC is 90 degree. This will be 90 degree. How can we prove? Okay, now it is quite easy. We know that ABCD is a parallelogram. This will imply in a parallelogram the sum of any two adjacent sides is always equal to 180 degree. So we will have angle D plus angle C is equal to 180 degree. Now consider this angle DE is bisecting the angle D. So one bisecting angle, let's say, is bisecting the angles into ADE and EDC. So let's say this is x degree. This is x degree, and let's say this is y degree. This is y degree. So we have this angle D plus angle C has to be equal to 180 degree. Now what is so x degree is nothing but half of angle D, and y degree is nothing but half of angle C. Since DE and CE are the bisector of the angle D and C, so we have this. So this implies x degree plus y degree is equal to half of angle D plus angle C, which is equal to angle D plus angle C is equal to 180 degree. So this is equal to 90 degree. So angle X plus angle Y is coming out to be 90 degree. Now in triangle DEC, applying the angle sum property, that is the sum of three angles in a triangle is 180 degree, we can say that angle DEC DEC plus angle x degree plus angle y degree should be equal to 180 degree. This implies angle DEC plus angle x degree plus y degree is coming has been found to be 190 degree. So we have 90 degree is equal to 180 degree. So this implies angle DEC is equal to 180 degree minus 90 degree, which is equal to 90 degree. So this implies that DE is perpendicular to EC. Or we have already found that the angle is the bisectors of angle D and C, they are intersecting at the point E, and so the angle formed is angle DEC, which is 90 degree. So the correct choice will be D. D is the correct choice. This is a very important result. You should always remember. Let me, okay. Question number 7. I'm having some problem with my machine. Question number 7 says that if an angle of a parallelogram is 2/3 of its adjacent angle, the smallest angle of the parallelogram is. If an angle of a parallelogram is 2/3 of its adjacent angle. Okay, so if this is the parallelogram, A, B, C, D. So let's say A and B are adjacent angles. So it is, let's say this be x degree. Let's not give some labels. So it is saying that one adjacent angle. So let's say in the parallelogram ABCD, let angle B is equal to 2/3 of angle A. So it is given that in a parallelogram, if one angle of a parallelogram is 2/3 of its adjacent angles. So A and B are adjacent angles, and we are assuming that angle B to be 2/3 of angle A. Now we know that since A and B are adjacent angles, angle A plus angle B will be equal to 180 degree. So this implies that angle B is equal to 2/3 angle A is equal to 180 degree. This implies, simplifying the left hand side, we get 5/3 angle A is equal to 180 degree. So this implies angle A will be equal to 3/5 multiplied by 180 degree. This is equal to 3 into 36 degree, which is equal to 108 degree. So angle A is 108 degree. It is asking the smallest angle of the parallelogram. Okay, so definitely angle A and angle C will be same. This is equal to angle C. So what will be angle B? Angle B is, we know, 2/3 of angle A, which is equal to 2/3 multiplied by 108 degree. This is equal to 2 multiplied by 36 degree. This is equal to 72 degree. Also we could have found angle B as 180 degree minus angle A. 180 degree minus 108 degree is 72 degree. So angle B, this is equal to angle D. Therefore smallest angle smallest angle is equal to 72 degree. 72 degree is the smallest angle. So the correct choice is B. The correct choice is B. Okay. Let's do problem number 8. The diagonals do not necessarily bisect the interior angles at the vertices in a rectangle. Definitely square. In a square, the diagonals always bisect the angles. In a rhombus, the diagonals always bisect the angles. And the fourth choice is all of these. No, the answer is A. In a rectangle, the diagonals do not necessarily bisect the angles. Okay. Question number 9. In a square ABCD, AB is equal to 2x plus 3 centimeter. Okay, let's see. Let's draw a square. So ABCD is a square. It is given that AB is equal to 2x plus 3 centimeter. AB is 2x plus 3 centimeter. BC is equal to, BC is given to be 3x minus 5 centimeter. Then the value of x is, okay. Now definitely in a square all the sides are equal. So this will imply that AB is equal to BC. So this will imply 2x plus 3 is equal to 3x minus 5. So solving x, this is a linear equation in one variable x. Solving x, we will get x is equal to 8. X is equal to 8. So the correct choice is D. D is the correct choice. Question number 9 is that question number 10, sorry, 8, 9, 10. Okay. Question number 10. If one angle of a parallelogram is 24 degree less than twice the smallest angle, then the largest angle of the parallelogram is, okay. So let's draw a parallelogram. So definitely in a parallelogram we know that there are only two angles. Since the opposite pair of angles, if ABCD is a parallelogram, we know that in a parallelogram there can be two different angles, because angle A is equal to angle C, we know, and angle D will be equal to angle B. So ultimately there are two different angles. So one will be whichever is greater, that is the whichever is larger of the two different angles. So in this of the two different angles in a parallelogram, the larger angle will be the greatest angle and the smaller angle will be the smallest angle. Okay. So if one angle of a parallelogram is 24 degree less than twice the smallest angle. Okay. So let's say let angle B is equal to, if one angle of a parallelogram is 24 degree less than twice the smallest angle. So let B, so in this parallelogram we can see that the smallest angle will be B or D. So let B be equal to x degree. So B is the smallest angle. B and D will be the smallest angle and A and C will be the largest angle. So this implies that it is given that if one angle of a parallelogram is 24 degree less than the twice the smallest angle. Okay. So we are assuming that angle B which will be the smallest angle as x degree. So definitely the other angle has to be either has to be A or C. So we can say that angle A or angle C, since they are equal, has to be 2x degree minus 24 degree. It is given that if one angle of a parallelogram is 24 degree less than twice the smallest angle, so the smallest angle is x degree. As per our assumption in this parallelogram, we are assuming angle B to be less than angle A. So definitely angle B will be the smallest angle, angle B and D will be the smallest angle, and angle A and C will be the greatest angle. We are assuming angle B as x degree. So definitely the greatest angle, which are A and C, has to be 2x degree minus 24 degree. Okay. Now also we know that angle A and angle B are adjacent angles in a parallelogram. So their sum has to be equal to 180 degree. So this implies angle A is 2x degree minus 24 degree and angle B is x degree is equal to 180 degree. So this implies, if we simplify the LHS, we get 3x degree minus 24 degree is equal to 180 degree. So this implies we have 3x degree is equal to 180 degree plus 24 degree, which is equal to 204 degree. 204 degree. So if we ignore the degree, we have 3x is equal to 204. So this implies x will be equal to 204 divided by 3, which is 68. It is asking the largest angle. So the largest angle is equal to A or is equal to C, and which will be equal to definitely angle A will be equal to 180 degree minus 60 minus what is B? B is x degree and x is 68. So 68 degree. Angle A and angle B, angle A plus angle B is 180 degree and angle B is 68 degree. So therefore angle A will be 180 degree minus 68 degree, which is 112 degree, which is 112 degree. So the correct choice is C is the correct choice. C is the correct choice. So this brings to an end in solving the problems of exercise 16B, which were multiple choice questions. Now, before I end this video, I would like to address something related to the previous video where I was solving the one problem from exercise 16A. 16A. Let me see if I can. 16A, where what was the problem? Where I would like to solve it again. In that solving the problem, I used the fact that in a two right angle triangles, if the hypotenuse is same and one acute angle is same, then the two triangles will be congruent. But as such, there is no such rule, congruency rule. In establishing the congruency relation between two right angle triangles. So if we have two right angle triangles, let's say ABC, we know the rule of congruency is RHS. RHS. So if these two triangles, these two triangles are congruent, then the hypotenuse has to be equal, that is AC has to be equal to XZ, and we already have the right angle triangle, and one side has to be equal. One side has to be equal. That is one side of the triangle ABC has to be equal to one arm or arm of the triangle XYZ. Then we can apply the RHS congruence criteria, that is right angled, hypotenuse and side. This has to be used. what was the problem? I think the problem was, let me see if I can. The problem was there was a rectangle. I think there was a rectangle. Sorry. There was a rectangle. And there was a rectangle and okay, so I think this was a problem. Let's say the rectangle is ABCD and we have the diagonal BD. We have the diagonal BD. Now we are drawing perpendicular from A to BD, and let's say this be E, and we are drawing a perpendicular from C to the diagonal BD. Let's say this be F. So we have to prove that the triangle, this triangle is congruent to this triangle. We have to establish the congruency between the triangle ADE and BFC. They are congruent. We have to prove. Okay. So as you can see that since ABCD is a rectangle, so it will also be a parallelogram. So we will obviously have these two angles equal, as they are alternate interior angles. Since AD is parallel to BC, and BD is a transversal, transversal. This will imply that angle ADE should be equal to angle CBF. Also we have this is right angle. Since CF is perpendicular to BD, this will be right angle, and also AED will be right angle, since AE is perpendicular to BD. So we have one right angle is equal, also AD is equal to BC. So AD is equal to BC. So one right angle is equal, one hypotenuse is equal, and we need to have now this fact that these two angles are equal will not help in establishing the congruency relation between triangle ADE and BFC. So we have the hypotenuse is same, AD is equal to BC, but the right angle, we have both the triangles are right angled. So we need equality of one arm of both the triangles, that is one side, either AE. We have to establish the equality of the corresponding arms of the two triangles. Now what we can do, we can prove that AE will be equal to FC. How? Consider the triangle in triangle AEB and triangle FDC. Consider the triangle, this triangle AEB and the triangle FDC, this triangle. We already have this side equal, that is AB is equal to DC. We have this angle, alternate angles equal, this angle will be equal to this angle. So we have angle ABE is equal to angle FDC. Also we will have wait a second. This side is equal AB is equal to DC. We have ABD is ABE is equal to FDC. What else can we have to establish the congruence relation? Can we have EAB? Okay, also you will see that so this is 90 degree, also this is 90 degree, and angle, so definitely we must have this angle should be equal to this angle, because let's say if so if I consider this as x degree and this angle, that is in triangle ABE AEB, if I assume the angle EAB is as x degree, and in and not this one, and in the triangle FDC, if I consider this angle to be y degree, eventually x degree will be equal to y degree. Why? That's what I am trying to prove. In triangle AEB, using the angle sum property, we must have x degree plus, in triangle AEB, one degree, one angle is 90 degree, so the sum of the other two angles must be 90 degree. So the other two angles are x degree and angle ABE should be equal to 90 degree. And in triangle FDC, similarly we will have y degree plus angle FDC should be equal to 90 degree. So this implies that x degree plus angle ABE should be equal to y degree plus angle FDC. But angle ABE is already equal to angle FDC. We already have this. So this will imply that x degree is equal to y degree, as we know that angle ABE is equal to angle FDC. Angle ABE is equal to angle FDC because they are alternate interior angles. Okay. So once we have this, so we will also have now in triangle AEB and FDC, we have AB equals to DC, ABE is equal to FDC, and also we got angle EAB is equal to angle FCD. So as you can see that we can establish, so this will imply all these three equality, that is AB equals to DC, angle ABE is equal to angle FDC, and angle EAB is equal to angle FCD. This will imply that these two triangles AEB and FDC are congruent, because we are satisfying the angle ASA criteria, ASA satisfied, ASA congruency satisfied, that is angle side angle. So in triangle AEB, the two angles are A and B, and also the included side is AB. And also in the other triangle FDC, the two angles, the corresponding two angles, the corresponding two equal angles are angle D and angle C, and the equal side is DC, which is the included side. So we are having angle side angle satisfied. So this will imply that triangle, what will be the congruence relation between AEB and FDC? So definitely it will be angle A is equal to angle C. So if AEB, if we want to establish the congruence relation between a triangle AEB and FDC, so angle A is equal to angle C. So this must be C, and angle B is equal to angle D. So it must be D and it must be F, CFD. So triangle AEB is congruent to triangle CFD. So this will imply that AE, this will imply that AE will be equal to CF. AE will be equal to CF. Hence we got that AE this is equal to CF. Now in triangle AED and FBC, we already have the one right angle. The right angles are equal. The hypotenuse are equal. That is, AD is equal to BC, and we are additionally having AE is equal to FC, which is one arm. So it will be hence we can say that so over here, and we have AE is equal to FC. AE is equal to FC. So all this fact we have. So all this fact that is AE is equal to FC, AD is equal to BC, and angle ADE angle ADE is equal to CF CBF. This is not required. So in triangle AE ADE and BFC, we see that both the triangles are right angle triangles, and we are having the hypotenuse are same, that is AD is equals to BC, and also one arm is same, that is AE is equal to FC. So this will imply we have AD is equal to BC and AE is equal to FC, and also they are both right angle triangle. So this implies RHS is satisfied, and hence I'm sorry, I really have no space. So now we can say that triangle ADE will be congruent to triangle. What will be the congruence relation between triangle ADE and BFC? So angle E is right angled, angle E and angle F are right angled. So definitely E will have correspondence with F. So we have F, and also we have AE is equal to FC. AE is equal to FC, and since E and F are having correspondence, so definitely A will have a correspondence with C. So this will be C, and hence this will be B, CBF. So triangle ADE will be congruent to triangle CBF. So this was one thing I want to address. I was solving this problem in the previous video while solving this is a problem from exercise 16a. So I hope this video will be beneficial to you in applying the concept of parallelograms in solving this kind of problems based on angles and the different conditions of a parallelogram and a quadrilateral to be a rectangle, square, rhombus, kite, and all the properties of diagonal sides and angles that defines a special type of quadrilateral. All these concepts will how to apply them to solve this kind of problems. So if this video was beneficial, then please like it, share it with your friends. And once again, please support me by subscribing to my channel and do not forget to press the bell icon so that you will be notified by my future videos. With this video, I have come to an end in discussing and solving all the problems from the textbook of exercise from the textbook of author RS Aggarwal on the chapter of parallelograms. Sorry, I will try to prepare 2 assignment problems based on the entire chapter of parallelograms, and then I will parallelly start solving 5 good problems in the other playlist, Maths 8 Hot, which will be relatively harder problems. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.